In this video, we're going to talk about circles. First, we need a good working definition of a circle. You, of course, know what a circle is, but we need something mathematically precise. So a circle is the set of all points in a plane, so like xy points, that are a fixed distance from a given point in the plane. So it still probably feels kind of vague. That given point, though, is called the center. And that fixed distance is called the radius. So hopefully that is starting to make more sense. So we have the center of the circle. Think about drawing a circle with a compass, and you put the pointy end of the compass where you want the center to be. And then the radius is how far apart the pencil is from that pointy part. So this distance actually to the circle, from the center to the circle, is the radius. And every single point that is r units from that center is going to be making this circle, if that makes sense. So since the circle is based on distance, it's the distance between the center and any point on the circle, let's write out the distance formula. So we're just going to kind of put everything in the right spot. So we know the distance between any point xy on the circle and the center hk is r, the radius. So instead of d, I'm going to put r equals, and then remember the distance formula, you have that big square root, and then it's the difference between your x coordinates, x minus h, the quantity squared, and then plus the difference between the y coordinates, so y minus k, the quantity squared, all under that square root. So now we can clean this up a little bit, square both sides, and we have r squared equals x minus h, the quantity squared, plus y minus k, the quantity squared. And then usually this gets flip-flopped around so that the r squared is on the right side, and we end up with this guy that's in the box. So we call this the standard form for the equation of a circle. So to write out the standard form for the equation of a circle, you need to know the center and you need the radius. So the center, it's x minus the x coordinate, h, and then y minus the y coordinate, k, and then equals the radius squared. So let's practice this just a little bit. State the radius and center and graph the circle. So we have x minus 4, the quantity squared, plus y plus 2, the quantity squared, equals 9. So we want to figure out what the center and the radius are by comparing to this standard form. So I'm going to kind of write it down here and sort of line it up maybe. X minus h squared plus y minus k squared equals r squared. So the radius is going to be, well, r squared equals 9. So the radius is going to be the square root of 9. So you're always going to have to take the square root when you're looking at the equation. Okay, the center can be tricky. Like, it's not complicated. It's just sometimes people get confused with the signs. So notice how our standard form has minus signs in it. So we're subtracting h, subtracting k. So that means if we're looking at the standard form, we have to think about what's being subtracted. Basically, just change the sign. So h isn't negative 4, it's actually 4. 4 is being subtracted from x. And then k is not 2, it's actually negative 2. And so let's kind of play with that a little bit just to make sure it makes sense. And then we'll look at the graph. So if I kind of put this back into my standard form, I would do x minus h is 4 squared. Okay, great. That looks the same as what we were given. And then plus, okay, y minus negative 2 squared. That doesn't look quite right, but we know that when you subtract a negative, if you have two minus signs, they make a plus, right? And then, of course, 3 squared, that's going to be fine. That's our 9. So if we go back to our equation, we can see why y plus 2 means that the k is actually negative 2. Okay, so let's draw this guy quickly. It's actually quite a bit easier to graph on MyOpenMath. It's easier to get the computer to do the circle, but that's okay. We can still make this work. Okay, so 4, negative 2. So we're going to plot our center first, even though it's technically not a point on the circle. And then we're just going to count however many units the radius is. So 3, up, down, left, and right. So up 3, and then down 3, left 3, and right 3. This grid's kind of goofy looking. Oh well. So now just you do the best you can to make it look like a circle. So sort of like that.